Okay. Anybody, any other questions? I think, yes, ma'am.
So, with one of the quizzes, the assignment, I think it said let me just try to find it so I'm not guessing.
Right, there you go. I don't want to do that.
It was an assignment statement quiz.
All
I
right.
didn't really understand.
All right. Remember we talked about the assignment statement, and we're doing it based upon 193, because eventually it's going to change. Remember we talked about an assignment statement solves an equation or solves an expression on the right, and assigns it to the left. Okay? So if I had something like 5 is equal to x, would that be valid or invalid? Invalid, because 5 is a constant. Whatever x is, I cannot take it and change what 5 is, right? That's invalid. That's 1. Now, we also talked about numeric and character data. For the beginners, we try to teach you or show you kind of stay in character. Character data can only work with character data, numeric only with numeric. So, if I have something like char letter equals 8, and then I say int number, and I say number equal letter. We don't want you to do that at this time. You know what I'm saying? That's invalid. Because you're trying to store character in the number. What happens is, you can do it, but it will not store the letter A in number. It's going to store a value from the ASCII table, which is 65. So we don't want to get to that yet. We want to make sure you're doing numbers to numbers and character to character.
So, so in the little thing,
It gave you like x is equal to char, whatever is equal to whatever. Float, whatever is equal to whatever. Int, whatever is equal to whatever. And then at the bottom, it took those variables and did some assignment statements, and you had to determine whether or not that character value can go into that numeric value. And that float value can go into that int value. Yes. That float value can go in that char value. And you understand?
was there a difference between them? It said number like NUN1 and then NU
M2.
Yeah, 2.
All right.
Yeah, was there a difference between those?
Those two, that's 2 different variables.
Okay.
But what were they specified as? They both was int, they both was float, they both was what? Or they both, number 1 don't have to be a number, it don't have to be int, it could be a char.
Okay.
It depends on how the user uses it.
One of them was like number 1 and number 2.
All right, and based on the top, what was number 1? Int? Oh, you can't get back to it. Okay. Well, I'll pull it up. Let's see. I don't want
It
this.
says int number 1, comma number 2.
All right, so both of those values are integer values.
Okay.
Remember we talked about how we can declare multiple values in one statement by just putting a comma and then a semicolon. So both of those are integer variables.
Okay, so
All right.
those were the same.
The same data type, but different variables. Yeah, remember we talked about that. All right? I could have a list of them, as long as I separate by a comma, end it in a semicolon.
Okay.
All right? Any other question? Another question? All right. All right, let's see what in the notes. All right, let's see what we got. Oh, yeah, we talked about that. Okay. All right. Now, we somewhat talked about this, but we can kind of look at it. All right? Because I think we had gotten to our expressions because you had your assignments. Now, we know that plus does what? Addition, right? One number plus another number. But in computer science, it could be what? One variable plus another variable, right? Minus, you're subtracting this minus that. Multiplication, which is the asterisk, this times this, okay? The division, okay, this divided by that. See? So, now, but when we get to the other one, mod is modulus, all right? So if I had something like this, x is equal to 10 modulus 3. What is stored in the x? Huh? A 1. Because we go, the modulus finds the remainder. So 3 goes into 10 3 times, right? 3 times 3 is 9 with what? A remainder of 1. Everybody understand? That's how the modulus work. Okay? And then we have this caret here, and that's for exponent. Now, you say, well, what that mean, Mrs. Sylvester? We know in math, I could do something like this. 2 cubed, right? I can do that in math, right? So that's what? 2 times 2 times 2, correct? Which is gonna give us what? What's the value? 2 cubed equal what? Huh? Class? 8. 2 times 2 times 2, right? So I could write this, as this. In math, you could do something like x is equal to 2 cubed, right? You can't do that like this in computer science. In computer science, you'd have to say something like x is equal to 2 caret 3. Everybody see that? Right? Now, some compilers it'll work with, some compilers it might not. Now, you can load the math library, okay? So you would do found include math.h, right? What this does, that loads all of the mathematical functions that you can use: tangent, cotangent, sine, power, square root, square. This is when you square something, you can use power. All right. So if I use this statement in my program and I wanted to rewrite this without using the caret, all right, I would have to write it in this format. First, I have to have this loaded. Then I could say POW, which is the function. Like I said, I could say x is equal to POW, all right, with the power function, and parentheses 2, 3, semicolon. And that's saying what? Raise 2 to the 3rd power and store the value into x. Okay? Everybody see that? So you see how a language, you're really doing some of the same things, but the language has its own way of going about doing it. That's all computer science is. All right? A different language, different way of doing something. All right? So now here it showed us the different ways we do that. All right? So now, here, order of operation. All right? Now, we all should know that what? If I have, I wish I had it. Okay. Erase. All right. Order of operation. So if I had x is equal to 2, well, let's see, I'll say 4. 4 plus 2 plus 1. What's that answer?
7.
All right. So what you did, this plus this, right? Correct? Now, if I did this, minus, what's the answer? Correct. 5, right? 4 plus 2 is 6, minus 1 is what? 5. I could do 4 minus 1 and get what? 3 plus 2 is what? 5. All right? Addition and subtraction has the same precedence. But when you work in an expression, you always want to work from left to right. You understand? Work from left to right. Now, this is the thing. If I did this, and I'll change this number, what's my answer now? Huh? Okay, so 2 times 3 is what? 6, and 4 is what? 10. We had to do what before we do what? Had to multiply before we add, because multiplication and division has a higher precedence than addition and subtraction. Everybody got that? Okay, so when you look at an expression, I'll take this. I could have left it. What's that answer?
8.
Correct. Because what? We have to do this first. You do multiplication and division before you do addition and subtraction. The modulus is on the same precedence with multiplication and division too, also. So now, you get this, and you get 4 plus 4, and that would give you the 8. Now, that works fine in that aspect. But what if I do this? X is equal to 4 plus 2. What I had divided. I had 4. That was 12 divided by 4. Let me write this up. 12 divided by 4. But then I did this. What happened?
16 divided by 4.
Huh?
16 divided by 4.
Because what I have to do, I have to do what's in the grouping, right? I cannot do the 12 divided by 4. You got what I'm saying? I got to do what's in the group and then work my way out. Everybody got it? So sometimes you have to do the grouping and say what? My precedence is out the window, because whatever inside of that group, I have to do it first. But sometimes you have precedence within the parentheses that you have to deal with. Once you get that value, then you're dealing with the precedence outside. Everybody got that? Okay? And that's what this chapter is kind of talking about. Look here. They got 17 plus X plus 21 plus Y. Just add them all up, you got your answer, right? No kind of precedence. It's just plus. Plus is a plus. But here, when we look at this, 12 plus 6 divided by 3. What do we do first? We divide and then we add. So 6 divided by 3 is what? 2 plus 12 is 14. So you understanding the order of precedence. Because you could write a formula. You know one formula that students get caught up with or mixed up with? The average function, the average expression. What you think they have a problem doing? If I had 5 scores, all right?
They don't put the adding into the parentheses first.
They don't group the adding, correct? Because what? If I had 5 scores, A plus B plus C plus D, that's B, plus D plus E, I can't divide that by 5 to get an answer like that, correct? Because I have to do what first? I have to get the total of everything. Because just dividing with the 5 without this is going to divide E by 5 first, and then add all the others, and now you're going to get may get a ballooned average. You understand? So a lot of times students make a mistake when they're trying to find an average. They don't find the total sum first, then divide by the count. Everybody understand that, right? Because you will get a totally different answer if you do it that way. All right? So, now, all right, so we just talking about this, and then like I said, we kind of explained it, but you should still read through the chapter to understand what's going on. Precedence, division, multiplication and division before addition and subtraction. All right? All this big part is saying. Same thing I wrote on the board. 6 divided by 3, you get 2. Then you add the 12 and you get what? 14. Okay? All right, here are some examples here. 5 plus 2 times 4. But now we have what? A grouping, right? So we have to do what's in the group first and then work outside of the group. So we're going to add 5 and 2. Then we're going to multiply all of that times 4. Because if I just did 2 times 4, then I would get what? 8, right? Plus 5, that's 13. Correct? Totally different answer, right? Here, 10 divided by 5 minus 3. 5 minus 3 is grouped. 5 minus 3 gives you 2, and then 10 divided by 2 gives you what? 5, right? But if you did 10 divided by 5 and get 2 minus 3, you get a -1, which is totally what? Wrong. Okay? So you got to watch the expression, pay attention. And many times when you're writing code, you might understand the expression. You may even how would I say it? Write it out on paper and get the right answer. But when you put that expression in your program, you need to make sure it is correct. Because missing a parentheses in the putting it in an improper place can cause your value to be different. All right?
Do you have to space out?
No.
Between
No.
like 10 and divide?
The white space in most compilers don't matter. Give you an example. I could put parentheses 5 and put 100 spaces plus 2. It's just gonna ignore those spaces and do whatever. I can write a statement, do 100 lines down, and start again. It's just gonna ignore those spaces, right? It's no big deal, right? All right, but I would tell you if you write some places you may want single space, so where you understand what's going on where, and make it more legible or readable. All right, So we got all these. Now look at this one, right here. What do we have to do here? Look at 8 plus 12 times 6 minus 2. What we need to do first here? We know we have to multiply before we add and subtract, right? But in order for us to multiply here, we first need to do what? Solve what's in that group. You understand? We need to solve this first to multiply by 12. You got me? So we need to solve this, which gives us what? 4. 4 times 12 is what? 48. Plus the 8 would give you 56. All right? So everybody see that. Then we have a grouping. You got this group divided by 3. Now we know we multiply and divide before we add and subtract, but those parentheses can cause us to have to do the addition. I have to do 6 minus 3, and then I have to do 2 plus 7. 2 plus 7 is what? 9. 6 minus 3 is 3. 9 times 3 is what? Wait, yeah. No, just give you a negative, right? 6 minus 3 is 3. And then 9 times 2, 9 times 3 is what? 27, right? Divided by the 3 gives you the 9, right? So you do the division last, all right? So like I say, that's why you have to take your math so that you can understand what is actually happening, all right? Looking at this program here. This program input test scores and calculates an average and displays it, all right? You say, okay, what happened? First of all, display enter first test score. So that's gonna be what? C out, right? Enter test score. Then what? Input test score, that's gonna be what? CN test 1. Then C out, we're gonna be C out in a second test score. Then we got input test 2. So that's C in test 2. But then we got what? Display in a third test score. And then what? That will be C out in a third test score. Then we got input test 3. So that would be C in test 3. So now we've collected what? 3 test scores. Each one of them put in what? A different variable. What are the variables? What are the variables? Test 1, test 2, and test 3, right? Now, this pseudocode did not show us declaring the variables, but we would have to what? Declare those variables so that what? The computer will, or the program will know that those variables are valid to be used in when it compiles the program, right? Everybody understand it? Now, here it says, okay, we've collected all the test scores. Now here is our expression to calculate the average. And what we're doing? Test 1 plus test 2, well, average is equal to, right? Set average equal to. So that's like saying process average is equal to test 1 plus test 2 plus test 3 collectively, right? Divided by 3. Right? Now, it's going to add them up, then divide by 3, and store that value into average. And now we can display the average score is, which is our string, and then the average. Everybody got that? Okay. Now, this is what I want you to do. Looking at this, right? And the thing is, remember, it did not declare the variable. What variables are you used in this program? Test 1, test 2, test 3, and average. So at the beginning of our program, we need to declare those variables. Now, this is another question. I'm looking at it and it's divided by 3. What could be the data type for these variables? Huh? It could be int or float. But just looking at the program, I would say it's probably going to be int because you're inputting the numbers, but you're dividing by a 3, all right? But it don't have to be. You can force it to be a float and get a floating point answer. But if you don't, you would get a whole number. Now, C++ does not automatically round up or round down. It's going to just give you that number, right, if it's integer. So what I want you to do is, looking at this, open up online GDB and write the program that will solve this pseudocode. Okay? So do your shell. Remember we talked about that shell. Do that shell first, and that's out the way. And then start doing your logic. Okay? And you're just looking at, you're declaring your variables, and you're just looking at the state, the flowchart symbols, and creating your statement, right? C out, C in, C out, C in, C out, C in, and then you got your average expression, and then C out your average. Okay? So go ahead on and type that code for that flowchart. So open up online GDB. All right, so that's the shell. And then all you're doing is put your information inside. All right? Oh, I need to move this over. So that would be the flow chart, the logical flow. And you might say, well, Mr. Professor, can I input the scores out of order? Yes, you can. But if you look at it, if a person have recorded 3 test scores, for a class, normally they're gonna record what? First test, second test, third test, right? So that way you can keep everything in order. And then if you ever have to do a class average on the students, your test scores are in the proper order, right? But it will still work no matter which test score you grab first, right? Because you're just collecting them and adding them together. So everybody declared their variables, right? Right? Now, you could declare them all individually, or you could declare them all together, right? You could do what? Int, I'm on the wrong page. You can do int, test 1, semicolon, int, test 2, semicolon, you understand? Or you can just say int, test 1, test 2, test 3, and average. Bam, 1 line. Either way, correct? Either way would be correct. But when you do one at a time, int, you have to use int for each one and a semicolon at the end of the line of each one. Right? So that's your declaration. So now you should be writing your statements, right? Couts and your CNs. You got it? Got it?
Yeah, yeah.
You get it?
Just using
Huh?
using the chart.
All right. All right, for the first one, I say display, enter the first test score. All you simply do is what? Cout. And I'll put a period and a semicolon. Because the semicolon goes at the end of this line. All right? All right. And then what? CN, the type. Test 1, right? That's gonna read in the first test. And then what? You just keep alternating, Cout, CN, Cout, CN, Cout. Hello, Miss? Miss?
Jessica.
Jessica. That's right? No, last name.
Oh. Gagina.
Gatia.
Call me what you want to say.
Why not?
I don't like.
Wait a minute, that's your last, you grew up with
Uh,
it? All right, so what we doing, we taking this flow chart, we went through it, and we went through order of operations, we went through the operators like addition, subtraction, multiplication, division, modular, and now we writing a program. This program allow a user to input 3 numbers and then find 3 test scores and find the average of those 3 test scores. So that's the pseudocode. So what we did, we went to the online GDB and we typing up the code. And this is the start of it. Yeah. All right. Anybody got it?
Wait, could you change something? Could you say instead of C out into the first test score, you say enter the first 3 test scores and put C in? Could you do test 1, comma test 2, comma test 3,
Not comma,
not comma?
not comma,
Oh, it'd be the
string.
yeah. So I could do that instead.
You can do that, but that's not what I asked. But you can do that. Yep, you can do that. But like you say, you would prompt the user and tell them, please enter the 3 test scores. Because otherwise they'll type 1 and hit enter and still waiting, and you're like, okay, what's going on? What's happening? Why is it not doing? And you try to keep hitting enter, they just gonna keep scrolling down. All right. Yes, ma'am.
So I've gone down to the input test 2, and then it has the A. That's average, right? A's.
What you say A? Right here? Oh, down here?
Yeah.
Oh, remember we talked about the symbols? We did the symbols? This here is a connector. What happens is you look at this A, you look at that A. Now, where's the arrow flow? Into this A, right? Where's the arrow flow here? Out of this A. So it takes you here and then takes you here. So that's how the logic flows. So it's just a connector to show you how the logic is still flowing from one place to the next. Yeah.
So how do you, what do you type for setting that?
What's that now?
Am I?
What happened? What you got? You got it? So, what I can do. Now, a more experienced programmer might do this. It's okay, but sometimes when you do this, you may forget some things and things could happen. I could copy this and paste. But I have 2 of the same, right? So I need to what? Enter the what? Second, and then what? Test 2, right? Everybody see that? Because you're basically doing the same thing, but you have to make sure that you modify it to fit, right? Because you can't have 3 input test 1, input test 1, input test 1, input test 1, right? For the same person at least. And then I could go down here and do the same thing. Paste. And this would be enter the 3rd. Right? Right, class? And now what we do, once we got the data, all we need to do is say what? Average is equal to what? Now this is why the problem, well, they give it to you in the pseudocode. Because what if I do this? What have I just done?
I did 3 for test 3, then added the other 2.
Right. So if I made 100 on test 1, 100 on test 2, and say maybe a 60 on test 3, it's gonna divide 60 by 3 to give me 20, and then it's gonna add 100 plus 100, and it's gonna be 220, which is totally what? Incorrect, right? So I need to do what to fix it? Parentheses, right? We gotta group it. We have to group it. Now what? We have to add first. So we're gonna add test 1, test 2, test 3 to get a total. So if test 1 is 100, test 2 is 100, test 3 is 100, we add them all together to get 300 and divide by 3, the answer, your average is what? 100, right? Everybody got that? So, Now, after you get the average, now we wanna what? You don't just do, write code to just write it. Now we wanna see our what? Results, correct? So to see them results, we do what? Cout, and you know I normally do /n/t just tabs you over, right? And then the average is, and notice, they put a space here, right? So that the number won't be right on the S, right? And then I stream what? Average. Right? And that's the program. Okay? So when I run it, hopefully all errors are gone. When I run it, it should ask me what? Enter first test score. Give me a test score. 92. Enter second test score. 73. Enter third test score. 100. All right. Now remember what I said. Being that all of my variables are integer, what's going to happen is going to find the average and give me just the what? The whole number. So, example, if this turns out to be 85.983, it's just going to give me 85.
So you would float it instead of being full.
Correct. Right. Or what you could do, we add that, and I think there's a round function too, where you can round up, right, and whatnot. So when I hit enter, and what? This is an average of what? 88. Right? So now check this out. If I made everything, and we use what? 92, 73, 100. Okay. So if we go over here and make this float, all right? And we divide this by 3.0. Okay? Now when we run this, 92, right? 73, right? 100. See what the actual average was? 88.33, right? So, and like I said, not dealing with averages, but if you was a construction worker, or a carpenter, or somebody dealing in designing and building, those 0.3, that 0.3 may matter, correct? Right? Or you cutting material short, or your building coming up short, your roof short. So it makes a difference as to what the data type is and whether or not you want that, depending on the type of work you're doing. Yes, ma'am.
Did you have to add the 0.0 at the end of the 3 for it to keep the?
Yes, ma'am. In that that goes into the next class where we talk. But I'm saying I could talk to you about it. Where you're talking about the precedence of the data type. I could have something as float data type, right? Correct? But if I input 92, input 70, input 100, that's whole numbers, right? And then I divide by a whole number, which is int, it's going to divide and give me an int result, no matter what.
So even though the floats are the test 1, test 2, and test 3, and you're entering the floats, it's still gonna consider them all.
Right, as long as if I put whole numbers, yes, watch.
Okay, I
Yeah.
got you.
And let me let my prove my statement. Hopefully it's gonna prove right. So what happens is I'll put 92, 73, 100.
It still work for me, yeah. Because 3 and 3.0 are the same thing, right?
No, it's not.
No,
No,
but
no.
I don't think that, but it's just the fact that you call them a float, so when you're inputting the scores, it's gonna float them with a 0 at the end regardless, so you don't have to divide by 3.0 because the numbers you're.
You have to watch this.
Are.
Check this out. This is it. All right. So this is integer, right?
Right,
This is integer. The 3.
right.
This will return an integer value, no matter whether this is float or not, because it's dealing with the right side of the expression. Okay. So now, so let's run it, okay? 92, 73, 100. You see what I'm saying? Because everything on the right side is integer.
Right.
I got integer values because it's test 1, test 2, and test 3 is int, and then I'm dividing by what? 3, which is what? Int. And so when I do that, it's gonna carry over or assign to the right side int. Now, if I do this, all of a sudden, float take precedence over int. So once I put 3.0 here, no matter how many int values I have, it's gonna promote that expression to a float value. And now when I run it, all right, 92, 73, 100. Bam. You see what I'm saying? So that goes into our that other class where you're dealing with promotion and demotion and whatnot. All right, with the data type. Okay? All right. Now, so everybody wrote the program, everybody compiled it, got all the errors out. Hello? Okay, so we kind of understand what's happening. Then Miss what? Sterling asked about the decimal place or the whole number, what's the difference, whatever. All right, which is a good question, great question. All right, so now, so let's look further on, all right? Now, this here, like I say, with some compilers it works, some it doesn't. So let's go back to our program, and let's just try to say, let's say we do something like int x, all right? And then I try to do something like x is equal to 2, what I tell you, carry 3. So that should give us what? 8. But let's see. Like I say, some compilers it'll work, but some compilers let's see. All right, so I'll run it. See, it gave me you saw it gave me 1. You understand? But if I would go in here and load this, then I can go here and say this is equal to all right, to that, oh, not a point period, come. All right, so now I can find 2 to the power of 3, right? So now when I run it, all right, bam, you see?
Right.
So it gave me the 8. So it just sends the
Should you test little stuff like that on the new compiler so you make sure you got like the right?
right, but I won't give you that because like some of it I done went through already. Yes, sir.
So after that X, and the last line you did a stream and L, wouldn't you get the same result if you just put the semicolon right after the X?
Well, yeah, but the NL just takes this information here and drop it down some.
Oh,
Yeah, that's all it does. It just takes that away from the output so you can just see what the output. That's all.
so for like assignments, you want that there?
Well, yeah, I would always rather you the very last statement you output put it in there at least 1, so that the compiler generated prompt wouldn't be right after the result. All right? Yeah. Just make it more legible, readable. You know what I'm saying? Right. That's all that's for. Just make it readable. You know what I'm saying? All right. So everybody see that S. Then I can change it to whatever I want. And like I said, I'll change the 5. What's 2 raised to the 5th power? Hello? Come on.
25.
What is?
32,
Oh, 2.
Yeah.
right?
What is?
It's 32.
You guessing. You thinking.
You made me sound like.
Right, it's 32. It's 2 times 2, which is 4 times 2, which is 8. Times 2, which is 16, times 2, which is 32. Alright? Alright. Now, okay, so like I said, you gotta widen. Now that modulus, okay, let's take this. Let's go back here. If I do x is 10 modulus 3, what's the answer for x? Alright, 1. So what I'm gonna do, class, I'm gonna just take this out though. I'll do slash asterisk, and what I'm gonna do a group comment. Hold on. Asterisk slash. Alright, so now when I run it, that's all I'm gonna get. See? What's the answer? 10 modulus 3 is 1. So what is
Do you need to include the math.h with that as well?
no. That's like adding and subtraction. It's just a symbol. Alright? Alright. So now, class, what's 17 modulus, let's say 6. What's 17 modulus 6?
5.
Okay, because what? 6 going to 17, how many times? Twice. That's 12. So what? 12 from 17 is 5. So we should get a remainder of 5. Alright? And bam.
So how did you cut out that? It's just the asterisk slash, or do you have to do 2
For what?
to cut out the top part?
To cut up to top? What you mean to cut up?
Like,
What I did a block, but you gotta do slash asterisk to begin a body, a block of comments, and then asterisk slash. You got me? See here? Slash asterisk started. And then asterisk slash ends it. Yes, and anything in between is not gonna be executed. Yes.
Okay, that was gonna be my
Oh,
answer.
man.
What does that do?
Yeah, that comment things out. And look, that's good sometimes, like you're writing code and you have a part of a program that you don't want to keep executing over and over, but you need it, you'll comment it out, run the program, do whatever. Then when you want it back, go ahead and comment it, take the comments out, and it run and do whatever. Alright? Alright, so now, okay. Converting math formulas. We as programmers, many times we may be working with people in different professions, right? They may have certain formulas, certain calculations they have to do, and they have written out in book form or whatever, right? So when you've given the project, you might be given all these formulas, and you will have to what? Take those formulas and write them out in an expression in the compiler so that it can be understood. By the understanding. So look at this. We just gonna kind of look at it in a common fashion. In math, 6b is really saying what? 6 times b, right? But in the programming world, we have to do 6 asterisk b, right? We can't just do 6b, and it understands that as, because what? It may try to think it as a user-defined variable, which it would be invalid because it begins with a number, right? But like I said, we have to use the expression and use the operator 6 times b. Now, look at this. In math, we know if we have something in parentheses and something else in parentheses, it's being multiplied. We understand that it's gonna be what? Multiplied together, right? So, looking at this, you can write it this way in math, but it's really saying 3 times 12. But as a programmer, you would write 3 asterisk 12. You gotta remember that when you type in in a compiler, every character has to have its own space. How many people remember the old typewriters? Even the old keyboard. You remember that one half keystroke? Never remember that where it had one half on it? So when you type it and you wanted to put one half on the paper, you press that key and it put one half. But in computer science, you would have to put one character, slash, another character, 2. You understand? You cannot put it all in and say, okay, that's one half. Can't do that. Every character has to have its own position. All right? So, look here. 4xy in math is really saying 4 times x times y. All right? So, in a program, we would have to write 4 asterisk x asterisk y. Now, ask you this question. If I told you, looking at that last expression, 4xy, I told you I wanted you to write a program to give x a value of 2 and y a value of 3, write the program to solve that. How would you go about doing it? Declare what? X, the y, and the total, your results, right? Now, but then you could assign, or you could have initialized it when you declared it, right? I told you x to be what? 2. So you could have done int x equals 2, comma, y equals 3, semicolon, right? Because I gave you the value. Now, once you have that, now you need to solve it, right? So what would be your third variable? The total, right? So how would I write that expression to solve? Total is the variable. Look at the right side of this page.
You put total equals 4 times x times y.
Bam. You understand what I'm saying?
Yeah.
So what it would do, it would take 4 multiplied times 2, you get 8, multiplied times 3 to get 32, right? And then, 24. And then store it in total, right? And then you can output total, correct? So you understand how computer science works. We taking variables, giving it values, and then we using expressions to calculate something, and then eventually output something of that, output some data. All right? Now, so look, this is some examples. See, look, this is raised to what? A certain power, correct? So you got all this, so you would have something where you would have to write this out. You can't write the expression in that form. It would have to say what? P is equal to, right? F divided by, and then a whole parentheses, right? Because all that at the bottom is the denominator, has to be all grouped.
Yeah, you do parentheses and the parentheses.
Right, to do the power and whatever. Correct? So everybody understand, you would have to know how to go about doing it, right? So, because what you can do, you can do power, and then you would do the 1 plus r, comma, n. You understand? And whatever n is, and whatever r is, gonna solve for that, and then the n is gonna solve for the power, and then divide that into f to get your result. Okay? Yeah. Oh. All right. Now, here's another one. Okay, but let's look at the next thing you're talking about. Variable declaration, which we talked about, and data types. What are some of the data types we talked about? Int, float, char, right? Now, you got, we get that normally in the other class where you have short, then you have int, long int, and then that double, long double, right? So you have data types, and then you can expound on those data types, all right? Those data types matter later on because depending on the data type determines the byte size and the range of values you can store in those data types, all right? All right, but a data type is simply the type of data that a variable gonna hold, all right? If I said something was of char, what type data is gonna hold? Huh? One character. Now, let me ask you this. What is a character? Is the number one a character? Right. Is the dollar sign a character? Is the divide symbol a character? Right. Any character you can type from the keyboard is a single character. Right? Char can be any character. Right? Numbers can be considered character. Right? But then when we get to the other data types, int and float, then we only dealing with, when we do int, we dealing with whole what? Numbers, and float, we dealing with decimal, right? Numbers, right? So you gotta keep in mind, and see integer, whole number, all right? So that's all it's trying to tell you. All right, declaring variables before using them. You have to, looking at this program, let's look at this program. Okay, I'm gonna take this out. All right, and I'm gonna do something. All right, so now, what I'm gonna do, here's where we're declaring our variables, right? What's the purpose of this? What's the purpose of declaring the variable?
Save it in a slot.
To create, allocate a space so the computer can know where to, well, first of all, the data type to store the data in, and where to store it or reference it, correct? Now, so take for instance, we don't have this at the beginning, but we have it at the end. What's gonna happen? We're gonna get errors. The computer will not know what in a test one. What is test one? You know, CN test one. What is test one? CN test two. It will say, what is test two? You know, average is equal to test one plus test. What is average? It won't know what those variables are, won't have a space allocated for them, and it won't know the data type. So it's gonna give you an error. So when I run it, watch what happens. You understand what it say? Test one, not declared. Test two, not declared. Test three, not declared. Average, not declared. X, not declared. But they are declared, but they're declared after what? Being used. Everybody understand that? It's almost like going on a website, but joining an organization. Before you are actually a member, you have to register, right? So the same thing here. Before the computer compiler can use a variable, it has to be made known that, hey, this is a variable I want to use, this is its data type, and sometimes this is its value. Now, go ahead on and do whatever. All right? So you have to make sure that, all right? Otherwise, you will get error. All right? Now, and you're like, well, Mr. Vesta said that's the right syntax. Yes, but what? Logically, it's out of order.
Is there a way you can find, like how you use math.h, is there a way you can find all those?
You probably can look online and find all the, like say if I go online, okay. And what you would probably do something like this, say like, okay, I would say this. Alright, so okay, library, let's see, functions, library, let's see this. And look, let's see. I want to find the library. I don't want to see that. I want to see the actual library function. There we go. Let's see, functions, built in, manage.h, yeah. So here, look around here, right? And they have some, like I say, I've never used this, return the nearest integer value.
Well, I was talking about instead of math.h, if there's a certain one you need to use, but you don't know what it is, how do you find that?
Like, okay, say what?
Why?
There are what, header files? I can just look up like all header files and they would give me the list of like all the different.
Oh, header file, right.
Like if I didn't know math.h existed, how would I find
Right.
Oh, you'd have to
Like
know.
now I know there's an IO
Right.
stream and there's a math.h and there's a string prepared.
Right, because you taking the classes now, you know, and like, you know, we tell you what, and now this is just a hypothesis. When the C, C++, C#, C++, when it first started, all your library was together, all right? But when you wrote a simple program, that made what? Your program what? Large, no matter if it was 1 or 2 lines, right? Because it had to load all those what? Libraries. So what they did with C++ said, okay, we're gonna allow the user to only load the libraries that they need when they need it to reduce the what? Size of the program so that it can load faster and it can run faster. So now a lot of that comes from studying, you know. Like, give you an example. There's vectors that can be used. Vectors, we talk about vectors when we deal with arrays, but that's in not the next class, but the class after that. In order to use the vectors in your program, you have to load the vector library. And then the vector library have all the different functions that you can use. Well, you can use all the functions for vector. String has a library. CC string has a library. F string, F stream has a library, all right? Because F stream deal with data files. So what I'm saying is like through teaching, yeah. And then you always could ask the question. You know, I need to use whatever in my C++ program. You know, what header file.
Google and see if you can find it.
Right. You know, but normally that's how, you know, that's those libraries. But I don't know of a location where it shows all of the library files, library files and what they do. Because it's split up. Anything you really want to do, there's libraries for.
Yeah, and you can make your own library.
Right. Well, really in my other classes, I show them how to create their own header file where they have to load, right? For each, but it's just a header file with the name, their name, the course name, the assignment name, and my name and the date. And then you have to load the .h file, but it's loaded with double quotes rather than the carries on each side. All right? So you can create your own header file, right? And then have functions in there to perform certain things, whatever it is you want it to perform. You can have a function to find the average of 2 numbers. You have You have a function to tell whether a number is positive or positive, negative, is divisible by 2 or not, or there's even or odd. You know, whatever it is that you're trying to do, you can have a library and a function that does it. All right. If you need to find the area of a circle or a square, you can have a library that you create automatically, and where it'll do that after you ask it for the information and whatnot. All right. So that's some of the functions of the math.h library. All right. So okay, back to here. No, back to here. All right, so make sure you declare your function, your variables, and all the variables that you're going to use prior to using them. All right, so look, all of a sudden now, look, declare real. What is real? Real numbers, which is what? Right, float, right? So it's a real, and this is basically what we did with the program, right? We did what? But we did int, like int test 1. Int test 2, int test 3. Then we did float average, right? Basically the same thing, but they write it in a little pseudocode. Then look, they said set test one equal to this. So now they assign it, alright? So test one equal 88, test two equal 92, 2.5, test three equal 97.